Hi Lakewood Math 1 students, this is Miss V again, and this is the fourth video in your series in your linear equations unit bundle. And in this video, we're going to learn how to graph linear equations if we're given the slope-intercept form of the equation. Notice in the problems that we have on this page, up until about problem 10, we're given the slope-intercept form of the equation. Once we get to problem 10, we actually have to put the equation in slope-intercept form in order to graph it, and that's just fine because we learned that in the last video. So let's do a couple of these. When I look at this equation, number one, what I notice is that my y-intercept, or my b value, is positive 3. And that means I'm going to have a point right here on my y-axis. X is 0 and y is 3. My slope is negative 1, which means I go down 1 unit. Excuse me, that should be a 1. I go down 1 unit in my y value for every right unit I do in my x value. So I go down 1 and over 1, and there's a point there. And I could just keep doing that and find my line. But I really only need to graph 2 points to draw this line. And I'm going to go ahead and use a straight edge so that we get a nice pretty picture of our line. And this is what the line looks like, y equals negative x plus 3. Now, we kind of have some ways to test for whether our graph is reasonable. One of them is we know our y-intercept is 3, but the other one is we know that we should have a negatively sloped line. In other words, it should go down when it goes left to right. Let's do number 2 together. We have a y-intercept of negative 4. Notice this is a negative b value. So I want to go to negative 4 on my y-axis. I have a point at 0, negative 4. In fact, the reason this is the y-intercept is because when x is 0, what is y? Well, let's just work that out. If I put in a 0 for x, I get out 0 here. So when x is 0, y ends up being negative 4. That's this point right here. My slope is 3, which means I go up 3 for every 1 unit I go over. So I can simply count 1, 2, 3, and 1. And there is my second point that I need to graph this line. My reasonableness test says I should have a pretty steep positive slope, and my line looks like it's right. So it passes my reasonableness test. In problem number 3, we have a y-intercept of 2, and our slope is positive, so we expect our line to be going like this. And I would go up 2 units for every 5 units I go to the right. So up 2 and over 1, 2, 3, 4, 5, and there's a second point. And I'm going to connect the dots. And there's my line. Notice how steep this line is. My slope is 3. Notice how flat this line is. My slope is much less than 1. So the bigger this number is, the steeper my line is going to graph. So in problem number 4, I've got a negative slope. I'm expecting it to graph down as we go left to right. And my y-intercept is right here at 1. And I can either go down 3 and to the right 4, because negative 3 divided by positive 4 is negative 3/4. So that means down 3 and to the right 1, 2, 3, 4. Or I could go up 3 and to the left 4. I could go up 1, 2, 3, and to the left 1, 2, 3, 4. And what do you know? All 3 of those points are on the same line. So I'm going to draw my line just like that. Okay, I'd like you to pause the video for a moment, and I'm going to, I'd like you to do problems 5 through 9, and when you're finished, I would like you to check your work and ask me some good questions. Here are the answers and what your graph should look like for problems 5 through 9. So let's hop down to problem number 10. All of a sudden I want to graph this guy, but he's not in slope-intercept form. That's not going to be a problem because in the last video we learned to put him in slope-intercept form, all I have to do is isolate the y on the left side of the equation. So it always begins by subtracting the x term, guys. And we have 2y is equal to negative x plus 4. And then I'm going to divide both sides of this equation by 2. Notice on the right-hand side, I have to divide both the x term by 2, and I also have to divide the 4 by 2, because we have to divide the entire side. We can't just divide half, one term or the other. So on the left, I'm left with y, and on the right, this is an implied negative 1. So I have negative 1/2 times x, and this is 4 divided by 2, which ends up being plus 2. So there's my equation in slope-intercept form. Now I can put a point at 0, 2, and then I'm going to go down 1 and to the right 2, down 1 and right 2, or I can go up 1 and left 2. Down 1, right 2, down 1, right 2, or up 1 and left 2. So down 1, right 2, up 1, left 2. And there's my line. And I'm going to use my straight edge again to draw a great line here. Let's do one more together and then you can practice. In this equation, the first thing I do is I subtract 3x from both sides. And I get negative 2y is equal to negative 3x minus 6. Now, notice, this is the pesky, I have to divide by a negative again. And if I forget, I'm going to get a slope that has the wrong sign in front of it. So negative 2, negative 2, and negative 2. These divide out to give me 1, so I have 1y. Negative 3 divided by negative 2 is positive 3 over 2. And negative 6 divided by negative 2 is a positive 3. So this is my equation in slope-intercept form, and I put a point at, let's see, I put a point at positive 3. And I'm not sure why this dot is there. It really kind of shouldn't be. I think my photocopier got a little excited about things, right? So we put a dot at 0, 3, and then we're going to go up 3 and over 2. Or we could go down 3, right, and left 2. Up 3 and over 2. Or down 3 and left 2. And we'll connect our dots. And there's our line. So pause the video. There are some problems on the next page that I'd like you to work and practice. Ask good questions, and then check your answers. Here are the answers for problems 12 through 15. Here are the answers for 16 through 19. And here are the answers for 20 and 21. Check your work, ask good questions. Don't forget to get the homework for graphing linear equations by slope-intercept form.